Hey, second graders, it's Mrs. Seals back for our next science lab. So we have finished up our unit on energy and we are starting a new unit on force and motion. So today we're going to be talking about one type of force called magnetism. So we're going to talk about what a magnet is, what sorts of objects are magnetic. So your target says, I can observe and identify how magnets are used in everyday life. So what is a magnet? A magnet is an object that attracts or pulls magnetic materials. Magnets can look different. Here are some different types of magnets that you have probably seen or you will see at school. This one's called a wand magnet. Whoops, I have one right here. Hold on, with some stuff stuck to it. Here's a wand magnet. They're all different colors. This one is called a bar magnet, and this one's called a horseshoe magnet. They all look different, but they all work in the same way, which is that they pull or attract items that are magnetic towards them. They can also push items away from them. We'll look at that in a minute. So what types of materials are magnetic? Certain types of metals, but not all metals. The most common type of metal that is magnetic is called iron. There's some other types called steel, nickel, and cobalt that are also magnetic as well. Some objects that are magnetic are a paper clip, a binder clip, screws, bolts, and nails. All of these objects are made up of metals, like I just mentioned on the slide before, that are magnetic. What types of materials are non-magnetic? Plastic, glass, cotton or any type of fabric, wood, rubber, and paper. All of these are non-magnetic, meaning they will not be pulled towards or attracted to a magnet, nor will they be repelled or pushed away. So how do we use magnets in daily life? A lot of people don't realize that a lot of our electronics have magnets inside of them. Speakers, televisions or laptops, tablets, cell phones, all of those things have magnets inside of them. Also, your refrigerator or freezer door, the seal that keeps it shut is magnetic too. That way it can make sure to keep the door closed tightly shut, because this part will have a magnet, this part will have a magnet, so they'll be pulled towards each other to make sure the refrigerator stays tightly shut. Headphones or earphones also have magnets inside of them. Credit cards have magnets in them. Lots of things that we use daily have magnets inside of them. So what we're going to be doing today in class is we're going to be rotating through some stations, 6 different stations, I think, or 5. 6 different stations where we'll just be exploring with magnets and looking at the way they interact together. Okay, so if you have a magnet at home, what you could do is you could do a little exploration at your home to see what sorts of things you can find that are magnetic and what sorts of things are non-magnetic. You could sort them. You could take a picture and send it to me. One sort of reminder is to make sure that you keep electronics and credit cards away from magnets. Magnets can destroy these things and keep them from working properly. So I just told you a second ago that a lot of those objects have magnets in them, our tablets, our cell phones, our laptops, our TVs. So if a magnet like this or something similar that's pretty strong gets near them, it can actually cause the magnets inside of them to lose their magnetism, which will keep them from working properly. Okay, so please make sure, I don't want any, expensive electronics or anything to be destroyed. So make sure you're staying, doing that correctly and staying safe. I would love to see what you come up with. Take a picture and send it to me. In class, I'm going to show you what the 6 stations are that we're going to be doing. The first station is called Go Fish, and I have these little cutout fish pictures with paper clips on them. And as we just saw before, Paper clips are a material that is magnetic, okay? So they will stick to a magnet. And each of these fish has a different number on it. So we're going to kind of combine some math in here with our science. What the kids at this station will do is they will take all of these fish and they will turn them upside down so they can't see what number is on them. All right, so those are their fish in the pond. This is their fishing pole. I have a pencil with some string, and this is what we call a ring magnet. So this right here is a magnet, which is going to pull the paper clips towards it. Okay, so when it's your turn, you go fishing, and when you go fishing, you just pick up 2 different fish. There's one, I'm going to set it over here, I'm not going to look at it yet, and there's 2. Okay, so I went fishing, I got my 2 fish. Now what I'm going to do is I'm going to look at the 2 that I caught. I caught an 8 and I caught a 1. So I'm going to add my numbers up. What's 8 plus 1? 8 plus 1 equals 9. So I got a total of 9, okay? All of the students, my partner and the other students in my group are going to also go fishing and add up theirs as well. So the winner of Go Fish is the person whose sum is the highest. So I got a 9. My partner will also go fishing and add theirs up. And if their sum is higher than 9, then they're the winner. If their sum is lower than 9, then I'm the winner. Okay? It's just for fun, just a way to explore magnetism and practice a little bit of math. All right? The next station is a race. And at this station, the students will have a wand magnet and a bar magnet. And you'll see that one side of the bar magnet is red, one side is blue. That's because magnets have what's called a north pole and a south pole. Have you ever heard the phrase opposites attract? What that means is that the north pole of one magnet, hold on, let me get one more of these. It'll be easier to show you. The north pole of one magnet and the south pole of another, those are opposites, north and south, those will be attracted towards each other. They will pull towards each other. Do you see how I have a blue and a red? Those are opposites. So look, they're pulled towards each other. They attract each other, okay? So opposites attract, but like sides repel. That means they push against each other. So what that means is if I have 2 sides that are the same, like a red and a red, they are pushing against each other. They're repelling. Okay, so I'll show you what that looks. I'll show you what that looks like right here. Ooh, do you see how it won't pick it up? It's not attracted to it. They're pushing against each other because I have the like sides. In order for it to pick it up, I have to have the opposite sides, a red and a blue, okay? So in this station, this is a race. You're going to have your wand magnet, and on one side of the table will be the starting line, one side of the table will be the finish line. You have to try and get your, well, that wasn't very good. You have to try and get your, there we go, bar magnet across the finish line first by using your wand magnet to push it across. But you can't touch your wand magnet to your bar magnet. You have to do it without touching them. When they do touch like that, or like mine just did, you have to start all the way back over. So let's see if I can do it. It's really hard. See how I'm pushing it without touching it? That's because the sides are alike and they're repelling. They're pushing against each other. Oh, it gets tricky when your magnet turns. All right, so that's just a little race to explore attracting and repelling. The next, whoa, these magnets are strong. The next station is called floating magnets, and this also deals with attraction and repelling. For this one, I'm going to be using more ring magnets, and I can feel that these 2 sides of these ring magnets, they're pulling towards each other. But when I flip one of them, Now they're really pushing against each other. They're repelling. So you're going to try and use that repelling force to see if you can get some magnets to float. So here's what I mean. I'm going to put one on my pencil. Then I'm going to take my other one. Oh, that didn't work because they pulled towards each other. Let's flip it. Do you see that? Do you see how it looks like my red magnet is floating? That's because the purple magnet and the red magnet are pushing against each other. They're repelling against each other. And that is causing the red magnet to float. Let's try it with this yellow one. See if we can get it to float as well. Do you see that? Now, my red and my yellow magnet are floating. Let's see if we can add my orange onto it. Whoa, I don't know if you can see that, but my red, my yellow, and my orange magnet are all floating because they're all repelling or pushing against each other. Isn't that cool? So that's called floating magnets. All right, I have two more stations. One of them is called chain reaction. The cool thing about magnetism is it can flow through some objects depending how strong it is. So for this one, you'll have some, like, I'm going to use these paper fasteners for this because they're very light and magnetic. And I'm going to pick one up, all right? And it's magnetic, it's sticking to my magnet. Now, oh goodness. Now what I'm going to do is I'm going to try and make, hold on, there we go, a chain reaction. So I'm going to see how, this is struggling today. All right, I'm going to see how many paper fasteners I can pick up, hold on, using my or just by using the magnetic force going through it. You know, this was a lot easier when I tried it a minute ago. Hold on. Okay, so finally I started my chain. So notice how this second paper fastener, it's not touching the magnet. That means the magnetism is going through the first paper fastener to the second one. So I'm going to see if I can pick up another. I got two more. So my chain is growing. Only my first paper fastener is touching my magnet. And then I have 1, 2, 3 more hanging on. So right now my chain is 4. Let's see if I can keep going. The magnetism is flowing through the brads. See if I can get one more on there. I don't know if, I don't think that the magnetism is strong enough. So there will be a point where you won't be able to pick any more up because there we go, the magnetism is not strong enough to keep going. So you're just going to see how many objects you can pick up before your chain breaks. I think I can only get 4. Yep, I think I can only get 4 brads on here. I don't think I can get another one. So my record is 4. See if you can beat it. If you have a stronger magnet, you probably can, or maybe use something else like little paper clips. All right, and then the last station is you're just doing a sort. There is this sorting mat that looks like this. One side says magnetic, one side says non-magnetic, and then you have a bowl of random objects. You're going to choose an object before you test it out. You're going to make a prediction about whether or not you think it's magnetic. I have a popsicle stick here. Popsicle sticks are made out of wood, and I saw in the PowerPoint that wood is a material that is non-magnetic, so I don't think it will stick to my magnet. So I made my prediction. I'm going to try. It does not, my magnet is not able to pick it up. It is not sticking, so I'm going to put it on this side of my sorting mat, non-magnetic. Let me try another one. Here's a binder clip, which is made out of metal. And I saw in the PowerPoint that it is a type of metal that is magnetic. And I was correct. It is magnetic. So it goes on this side. And then my partner and I will just keep going and sorting all of the objects. All right. And then the last station, the students will be completing a paper where they will draw 3 things that are magnetic and 3 things that are not. All right, so I hope you had fun exploring with magnets today. I hope you get to do some exploration at home. Again, I would love to see what you come up with. Please make sure you are keeping your magnets away from electronics so we don't have anything destroyed. All right, I hope that you had fun, and I will see you guys next week. Bye.